Take a look at this mechanized assembly line. When most organizations adopt AI, they ask, how can we use this to do today's work faster? This pursuit of pure speed often creates chaotic, fragile systems driven by brute force automation. ABQ-IT approaches the problem differently by building systems that get smarter every time people do their normal work. Optimizing for speed alone produces rigid automation. Designing for daily knowledge capture builds a resilient organization that learns from itself. Consider a specialized engineering services firm. To review complex construction documents and draft customer proposals, this firm relies on a handful of highly experienced professionals. The process works, but it carries severe operational constraints. Review speeds vary by engineer, and critical institutional knowledge remains locked inside the minds of these few veterans. This diagram illustrates the mathematical limit of their setup. A massive volume of incoming project data is squeezing through a narrow pipeline of human nodes. To scale output, the firm would have to hire more of these rare, expensive experts, a finite talent pool. AI adoption converts the silent judgment of these experts into a permanent, compounding asset that the entire organization can draw from. ABQ-IT tackles this through a phased methodology. Phase 1 is workflow discovery. They establish a baseline of operational intelligence by mapping out specific decision points, carefully separating repetitive choices from the actions that require true human judgment. That mapping leads to Phase 2, AI-assisted execution. Here, ABQ-IT builds a parallel workflow where AI operates behind the scenes to ingest project documents, classify equipment, and draft initial proposals. A strict governance rule sits at the center of this system. The AI only proposes. The human engineer retains absolute decision-making authority over the final product. By keeping the engineer accountable, the organization strips away the manual administrative burden while maintaining absolute trust in the final output. Traditional enterprise software stops learning the moment it produces an output. ABQ-IT solves this by introducing a mechanism called correction capture. When an engineer adjusts a quantity, fixes a false positive, or reclassifies an item, those actions trigger the loop, routing specific data directly back into the central AI node. Engineers simply do their normal work. The act of approving a draft automatically spawns the training signal in the background without requiring a separate report. The sequence moves quickly. The human action feeds the correction capture. Those packets enter a pattern detection phase, and the central AI implements the change. The architecture permanently alters to absorb that new knowledge. Expertise now accumulates within the system itself, making the firm less dependent on the specific individuals who made the initial corrections. Every completed project automatically increases the baseline intelligence of the entire organization. Correction capture transforms the act of working into a direct engine for continuous institutional learning. This forms an AI-native operating model. The sensing layer ingests raw documents. The interpretation layer categorizes data. The decision layer generates recommendations. The governance layer lets humans validate decisions. Finally, the learning layer sends structured feedback down to improve every tier for future tasks. Reaching an AI-native state is often mistaken for a plan to eliminate the human workforce. In reality, the engineer's role elevates. They spend less time on administrative counting and more time applying professional judgment to handle complex exceptions. ABQ-IT builds permanent mechanisms for institutional learning, prioritizing a long-term intelligence layer over static features that simply mask flawed processes. An organization whose operational knowledge continuously compounds creates its own intelligence layer. That compounding knowledge becomes a durable, uncatchable competitive advantage.